Okay, so we're gonna do a math problem with my favorite Disney princess. How's your social distancing going, by the way?
It's going so. My siblings are like going crazy and driving me up the wall, but it's okay.
Wait, how many siblings do you have?
I have 4, but 3 including me.
Oh, okay, so there's 3 siblings, but like 4 children total?
Yeah.
Okay, then I have the perfect math problem to do with you, actually.
Okay.
Perfect. Well, why don't we do a math problem about a family with 4 kids? You want to try it? I know you love math.
Yeah, that's my favorite subject of all.
Oh my God, I'm so excited then. Okay, just like yours, there's a family that has a total of 4 children. And the gender identity of the children are listed in the order they're born. So like there could be a boy, a boy, a boy, a boy, or maybe there's like a boy, a boy, a boy, and then a girl. By the way, what's your family? What's the oldest to youngest? What are the gender identities?
Girl, boy, and then another girl and a boy.
You're the first one, right?
Yeah.
You forgot yourself for a second?
Yeah, I was like, boy? I'm not a boy.
So like your family, there's a family with 4 children. There's actually 16 possible outcomes. Did you know that?
No, I did not know that.
Now you do. So here's why. When the first child is born, there are 2 choices or 2 options for the gender. So like when you were born, you could have kind of come into this beautiful world identifying as male or female, right? Mm-hmm. We're being really binary about it, just calling it 2 options. And then for the second child, there were 2 options. And then for the third child, there's 2 options. And then for the 4th child, there's 2 options. And then we multiply in between. So what does 2 times 2 times 2 times 2 come out to?
16.
Yeah. 16 possible outcomes. And they list them all here for us, like all the possibilities. So wait, you said yours was girl, boy, girl, boy?
Yeah.
Okay, so here's your family right in here. So the probability that your family would have occurred, there's a 1 out of 16 chance. Because there's 1 that looks like your family out of 16 total possible family dynamics. Does that make sense?
Yeah.
Okay, so we're supposed to go ahead and find the probability distribution for X if X represents the number of girls. Because girls, you know, we're like the best.
Yeah.
So X equals the number of girls. So we're going to create a probability distribution for X, which is just like, let's list out what all the possibilities are for X. And then we're going to also write out what all their probabilities would be. So if we have 4 children, okay, bye, Dexter. My child just left. What are all the possibilities? Like X could be, if X is the number of girls, you could have a family with 0 girls. Mm-hmm. What else? You could have a family with
1 girl.
Or
2 girls.
Or
3 girls.
Yeah, or lastly, all 4 could be girls, right?
Yeah.
So basically, all the possibilities for X are the number of girls could be 0 girls, 1 girl, 2 girls, 3 girls, or 4 girls. So we started our distribution, and now we have to write what are all the associated probabilities. Dexter! Oh my God. Can you hear him?
Yes.
I'm working. Mommy's working. Dexter, stop. Get right here. Okay. So now the associated probabilities are, let's go ahead and use some color to help us. If X is 0 girls, then we can look up at, remember this, what's called our sample space is all of the possible outcomes. So all 16 outcomes are here in yellow. What's the one case where there's 0 girls?
There's all boys.
Okay, so that would be boy, 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 boy. And there's only 1 situation where that happens. Mm-hmm. So the probability that we get a family that has no girls, meaning it's all boys, would be, well, how many ways can that happen?
1 way.
Out of how many total ways to have a family in this case?
16.
Cool. So we get 1/16, and then we can go to our calculator and see what that is. I think it's like 0.06 something. Yeah, so 0.0625. Cool?
Mhm.
Okay, let's now look at a family that has one girl. So if there's one girl, that girl could be like the youngest. Like I'm going to highlight in purple, see this family?
Yeah.
Or she could be the second to youngest, she could be the second oldest, or she could be the oldest. So how many total ways are there to have one girl in this family of 4?
4.
Yeah, 4. Out of how many possible ways to have a family?
16.
Mm-hmm. And then so when we divide that, we get 25% or 1/4. Cool. So now let's look at families where there are 2 girls. You could have, and that's your family, right?
Mm-hmm.
Okay, but this one isn't yours. This one is. But both, see how both those in blue have 2 girls in them?
Yeah.
Okay, and then we could have the 2 girls could be in the middle. The 2 girls could be on like the outside, or the younger 2, or the older 2. Okay, so how many total families are there that have 2 girls?
6.
Out of how many total families still?
16.
Cool. And then 6 out of 16. Grab your calculator, Genesis. I know you're doing this with me.
0.375.
Oh, cool. Thank you. Okay, let's continue. We've got 2 more to do, and then we'll have this all wrapped up. There could be a family with 3 girls. All right, so then we go back up to our sample space and look at all the families. I'm going to use orange for 3 girls. The 3 girls could be the younger 3, or they could be kind of separated into these different ways. But how many total families have 3 girls in them?
4.
4. Out of how many total families?
16.
Yeah, so 4 out of 16. We already saw that. And that already came out to 1/4, so 0.25. Okay, lastly, we could have a family that is all girls. And there's only one way that could happen. That would be girl, 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 girl.
Mm-hmm.
So what's our last probability here?
1 out of 16.
Yeah, there's one way to have that out of 16 possible ways. And we already saw that that comes out to?
Give me 1 second.
Okay.
Zion, shut up! Okay.
Speaking of siblings.
Back to the lesson.
Okay, let's see. Oh, 1 out of 16. What does that come out to?
0.0625.
Okay, and then we always remember to total up our probabilities. So when we add all these up, what should they always come out to?
1.
1, because the probability has to be 100%, right?
Yeah.
And if we had added it up in fraction form, notice that out of 16, we would have had 1 plus 4, which is 5, 6 plus 4, which is 10, plus another 1. So 16 out of 16, which also is equal to 1. So we would have been able to check our work, and we would have known that we rocked it. Yet again, we're amazing.
Period.
Nice job, Genesis. I never knew you were so math savvy.
Yeah, I love it so much.
Oh my gosh, we're going to do so much math together over this quarantine.
Yay! Woo-hoo.
All right, thanks for helping me and my students.
You're welcome.
Hi, Genesis. How are you?
I'm good. How are you?
Little by little, more animals are going to go extinct, and then there's not going to be animals on the planet, and that's not going to be good.
So cute.
I know.
I've never seen baby possums.
Genesis told us from an early age that she was here for a reason.
Oh, it's okay.
She told us, I'm here to help save animals and humans because we're all connected.
So do you think like this was someone's pet?
Most likely.
I can feel like other emotions of people and like animals.
Or you want to feed them? Put a bunch in, they'll love it.
If I could picture my world, people wouldn't be able to kill animals and hurt them.